الإخوة الأفاضل الأخوات الفاضلات، مرحبا بكم على منصة إناس. Part 2 Material Testing Part 2. نبدأ إن شاء الله for the outline. بالنسبة للبارت 1 كنا رأينا overview of material testing وكذلك role of material testing in engineering and manufacturing. هذا كان في السابق. أما اليوم Part 2 سوف نرى failure criteria examples. هذا إجابة على سؤال ربما هذه أتركها إلى الأخير. Just a question was raised at the last webinar. They need some examples, so I have a couple of examples. Maybe at the end, if we have time, we're gonna go over that. ثانيا material testing, AI and ML وعلاقتهما بذلك واستعماله في الماتيريال ساينس. وهناك كذلك نقطة مهمة independent وهي laboratory testing and accreditation. طيب بالنسبة رايح نجوز على الفايلر كرايتيريا هذه نمر عليها مرة الكرام. طيب and material testing and AI and ML. AI artificial intelligence and machine learning has started for the material science, concerning the material science in about the 2010, and it's boomed especially in 2019, right before the pandemic, and it's really now going a little bit fast, and it's getting a lot of attention these years. طيب material testing and AI and ML. أولا نبدأ بالdefinition of artificial intelligence كما نفهمها في material science. So artificial intelligence, AI, is the simulation of a human intelligence in machines programmed to think, learn and solve problems. وإن كان ال AI وال ML they are used interchangeably. يعني so many people they use them as the same thing. لكن في فرق بسيط طبعا. فهنا كاين two keywords. هنا كاين programming وكاين artificial simulation. So ما هي إلا تقريبا program computer programming languages مستعملة لتفكر يعني to simulate the human being في التفكير وفي حل المسائل. وهناك عدة لغات تستعمل في ال AI. كاين البايثون أشهرها Python language, it's widely used, وجافا وكاين C++, وكاين R which is R language which is a statistical language, and it's also a data language. And Julia also, Julia it uses Python and C++, يعني خليط ما بين البايثون والسي بلس بلس. وكذلك MATLAB, MATLAB Matrix Laboratory. هذه اللغة عادة مستعملة كثيرا في الجامعات لأنها many formula are already predefined in this language, and students like it, and it does so many things: simulation, it does solving problems, prediction, so many things. وحتى فورتران، إذا ما تسمعوا فورتران formula translation، هذه لغة قديمة كانوا يستعملها كثير في البداية. الجامعات كانت تستعملها، كانت عامة تقريبا، وتبقى ما زالت فورتران اللغة يعني هي القوية، خاصة in scientific in formula and calculations. وتستعمل قليلا هنا، يعني يستعملونها في ال AI في بعض some subroutines, some tasks they use the Fortran. and آخر update للفورتران هي 2018. طيب هذا بالنسبة لل AI. هذا مثال، يعني كنا أمثلة كثيرة. يعني هنا ترونه في الصورة it's supposed to be follow me drone. يعني طلبت من أحد الأولاد أن يبحث لي عن صورة للدرون أو أي مثال اللي فيه ال AI، فهو رسم لي follow me drone وأصر علي باش نديرها في السترا ف مليح أحيانا الأطفال تعطوهم tasks عوض أن يبقوا دائما منشغلين بالجيمز وهلم جرا. It's good to keep them busy and give them some work to do. Tell them I need this, I need this, and they do a good job. ومن الأمثلة كثيرة. كاين هذا follow me drone يستعمله كثير من اللاعبين، يستعملونه للهايكرز في الجبال، يستعملونه في كثير من التطبيقات. وكذلك هناك تطبيقات أخرى، السيارات طبعا. السيارات الآن أصبحت عادية مشهورة، تستعمل الاي اي في السيارات. بالنسبة للماشين learning, a definition, machine learning ML refers to the set of algorithms and techniques that enable computers to learn from data and make predictions or take actions based on that learning. So هنا two keywords. So you see algorithm and data. هذا ما تحتاجه الماشين in a machine learning. This is the two main thing. هي عبارة عن algorithm, different type of algorithms, and data. It's كل مرة takes more data. The more data it takes, the more output it gives you good results. وعلى فكرة algorithm هذه جاية من العلامة المسلم محمد بن موسى الخوارزمي في كتابه الجبر والمقابلة. هو أول من وضع قواعد he initiated the basics for the algorithms. ونعطيكم مثال المثال على ذلك. فمثلا for example you have a set of data x degrees of freedom, y let's say its mechanical properties اللي شفناها من قبل في part 1. There are many mechanical properties اللي ركزنا عليها. هنا عوض، يعني خلينا نعطيكم البيان. عوض باش نقول هنا instead of saying independent variable هذه x used to usually when you present a function y function x, usually x is the independent variable, but هنا when you are doing an experiment it's better to use degrees of freedom، لأن degree of freedom عنده مجال في التغير مهما كان. قد يكون رقم عددي وقد يكون مادة أو أحد مركبات المادة. فهنا في هذا البيان in this graph you see three things. You see machine learning modeling, you see the real curve. So let's say I did some material response, some mechanical property, material response to a certain degree of freedom. يعني قبل حتى نوضح degrees of freedom مثلا let me give you concept تاع degrees of freedom حتى على الأقل نربطه بما what we are doing here قبل أن أشرح هذه curves. degree of freedom مثلا in kinematic الإنسان human being, how many degrees of freedom he has? He has 3 degrees of freedom. يمكن أن يتحرك. أنا بالنسبة للحركة in kinematic يعني يمكن أن يتحرك in the x direction وممكن يتحرك in the y direction، لكن ال z direction vertical he cannot move, he cannot fly, he can rotate only. So عنده x, y and rotation, so 3 degrees of freedom. بالنسبة للطائر in 3 x, y and z الطائر يتحرك along x, along y, along z ويستطيع أن يدور can rotate around x, around y, around z. So عنده 6 degrees of freedom. So هذه باش نقرب المعنى نتاع degrees of freedom. فهنا on the x we have degrees of freedom. Y, a response of the material response. It could be ultimate strength, it could be yield strength, it could be the modulus of elasticity, it could be fatigue, it could be one of these properties. For the real curve هذا الأورنج هذه إذا if we do the experiment, millions and millions of experiments, we obtain this orange curve, which we cannot do it, but we are supposing this is the curve obtained by doing all the experiment. لكن في الحقيقة, in reality, we can do just few experiments. That's what we are able to do. The dots, the black dots, it's the number of experiments that we performed. So هنا the role of the machine learning, the modeling, the machine learning, it will use the best fitting to this, the best curve that can go through these points and predict what's missing. So يعني تقريبا هو هذا الازرق وهذا الاورنج they are تقريبا متقاربين. يعني هذه كلها تكون تقارب معقول واكسبتد. فهنا how we use the machine learning in describing first the data, these dots, and predicting the missing data. So with a bit of experiment, we can predict the missing data, and we can, and the machine is learning. مثلا we did this experiment. Next time we do more experiments, we feed the machine learning, we feed it, ونعطوها المعلومات, so it's gonna give me more precise output. So this is the idea of machine learning in material science. So in other disciplines is differently. They applied, I don't know how they do that, but they do differently. مثلا electrical engineering or chemistry or whatever in any other discipline. طيب, now using the AI ML in material design. So let's say I have one type of material which is steel C1018. هذا أحد أنواع الحديد. It's this C1018 has a composition, it's composed with Fe. Fe is the iron. يعني هناك فرق بين الستيل والiron. والiron. نعم. Iron, it's an element in the periodic table. You don't find steel in the periodic table. But Fe بالعربية نقولوا حديد, وهذا فولاذ. فالحديد هذا iron is the base metal. Usually it's in هنا يكون تقريبا 98% 99% في هذه الحدود. هذا for the C1018 it has 0.18% carbon content. manganese it has 0.6%. phosphorus it عنده 0.04%. sulfur عنده 0.05%. So هذه تقريبا, يعني قد تختلف هذه النسب من it depends on the وعنده كذلك traces of other impurities. كاين شوائب قد, يعني في كل الصناعات كاين شوائب. So we are assuming that this has this composition. It depends, يعني هناك من معمل إلى معمل تختلف هذه النسب قليلا. It depends on the process of production في manufacturing, how they get their production, the process they use. So النسب هذه تختلف. لكن حاليا let's agree on this نسب في C1018. وهنا we test this one. We put it under the test, under tension test, to get the mechanical properties. وهذه تكلمنا عنها في الحصة الماضية. So we got a bunch of properties like modulus, the yield strength, the ultimate strength, the slope of this linear part, which is the modulus of elasticity. Area of this triangle is the modulus of resilience. Area under the curve is the modulus of toughness إلى آخره. يعني كثير من mechanical properties نحصل عليها. يعني من هنا حصلنا على هذه المعلومات. ففي let's propose the following problem here given. So this a problem. We assume this problem. Given the mechanical properties of steel, that's sigma y, sigma u, ultimate, modulus of elasticity, fatigue, etc. We have a bunch of properties which are I have them. You know, I didn't perform any test. I didn't do any testing. I just started with this mechanical properties, and I asked the question: what would be the composition of this steel? أنا اخترت different properties هنا, different numbers, and I said I do the opposite. هنا من هنا I want to the here. Now from the curve I want to go back. I want to see what type of steel I am going to have. هذه it's very important. and هذا واللي راه مهتم به الآن the AI and ML use in material design. It's really getting so much attention, and a lot of research is that it's happening now. طيب, design. Let's look at the design using AI ML. So let's look at the direct. I want the forward method. يعني من هنا إلى هنا. When we go from steel with these compositions to the properties, so mechanical properties. So now I did it by hand. This is the correct way to get the mechanical properties. From this information I get the mechanical properties. لكن ممكن نستعمل also the AI and ML to do that, to go from here to here. And that's what we call design using AI and ML. So عندنا material composition and processing. We have this. We have this. What I mean by this is this. Okay, these informations. So we have this, and we will the machine, the AI and ML will give us the predicted mechanical properties. It will give you some properties. If you give her this information, it will give you, because it has, you know, the AI has all the programming languages and has all the programming to do the tasks, to do the calculation, the physics, everything. And ML, it will do the rest. It will get the data and get you the predicted mechanical properties. كيف يكون ذلك؟ بما يلي. فأولا نأخذ هذا material composition and processing, have all this information. مثلا steel C1018, need coya manganese, sulfur, blah blah blah, all the component. And then we give him a given physics simulation. Physics simulation, it's all, we simulate the physics law, for example, Newton's law, law 1, 2, 3, and all the equilibrium equations, all that stuff that we use in physics to get, let's say you have external forces and you would like to calculate the reaction in that material. It's, it's through physics. So we do simulation to that, and we give all the information needed. The type of steel, the density, the dimensions, all the physics laws, etc. And some experiment. For example, you did tension test, compression test at a different temperatures, high temperature, low temperature. We give all the information. And we choose a machine learning model. There is certain models now in the market. You can usually people, they use what's existing now. You can't invent, because this already used, especially machine learning. It's already has some data in it, and if you give more data to that model, it's good. Always it needs data. The machine learning needs data. It learns from the data, and it gives you the predicted properties precisely. Not precisely, it gives you some numbers, of course. It gives you some results. This, this is really, it gives, it has a degree, a certain degree of accuracy, which is really good and accepted. And when you get the predicted properties, you can check them, of course, by doing some experiment. You will see you are in the right direction. Now let's do the inverse design using AI ML, which is the most important. That's the point here. That's the most important now, because going this way from here to here, it's really easy and feasible. But the inverse design, this is the most important thing, because if you are able to do the inverse, that's it. You're gonna find so many um, interesting results. So you have the mechanical properties, and I would like to find the composition and the processing that I need to make this this material. Because you play with the mechanical properties, you choose the properties, you choose what's suitable for you, for your design, and then it's gonna give you the optimized composition and processing. How to do that? By the following. So you have the mechanical properties ready, the constraints also. The constraints, it's actually the limit states, you don't want it, when you give a properties, you don't want to find a material that meets these properties with any type of, but there is a certain temperature you need, there is certain limit, because it, the calculation, there is a huge calculation, the AI and ML, it's a huge calculation, really, and then you need, you don't need the regular computer to do that. Sometimes you don't need a regular, you need a supercomputer to do that calculation. These constraints could be a temperature, it could be the forces, the limit in the force. You can't just leave it like that to infinity or minus infinity. You can't do that. Some limitation in your, because the machine, the AI, it's a machine. It doesn't understand when you ask a question. It's just gonna go to the extremes. So it is gonna give you an error at the end. So you have to give some constraints. This is the range that you have to stay in it and find the material. And here a sequential learning. I'm gonna talk about this sequential learning in a moment. After doing some loops here, I'm going to explain that. Then it gives you it will propose the machine learning model. It gives you some proposition. It proposes some material composition and some processing. So probably you start with some properties. These properties have a lot of combinations. So for example, um, when you start with, let me go back a little bit. When you start, for example, when you say, I want this. So here, when changing this content, program is carbon content, it changes a little bit carbon content to see the effect in what you are looking for, and it change the effect of this, change the effect of this and this. So all this 1, 2, 3, 4, and 5 degrees of freedom here, and each one is changing, and they do some combination. It changed this one, then this one, then this one, then this one, then it changed a little bit this and change the rest in a wide range. So it's you think about thousands and thousands of combination. It will be done by the machine. So here, and it gives you some optimized. It gives you some good. Maybe you start with the combination, maybe a million. It gives you here maybe a half of that. Then you go back, you do some correction. This models that what the machine proposed for you, you gonna have, you can't test all of that. So you're gonna do some elimination. You take only maybe 1,000, and you test it. What's feasible to be tested? You're gonna test it, and you go again. Give the data to the machine, and after you give the data, it gives you more accurate and less numbers. And you keep going until you end up by few optimized proposed compositions, and then it's easy for you to test them and use them. Here, the sequential learning. Sequential learning, it's really important and it's really difficult, and someone who does that needs really to understand the material. Even though the references that we have, all these seminars, these webinars, all this information about the material, and still we don't know a lot about material, the behavior of material, especially the structure. When it comes to the structure, it's really difficult, and the interaction within the composition of that material. So we start with a certain composition here and processing, and then you give it to a certain model, to a model of machine learning model. It will do the calculation, do all the optimization, and gives you it proposes some items, less items than you entered here. Those items, you do not do some experiment. This experiment, of course, you're going to get some data. This data, machine learning likes data. You have to give that data to the machine learning. It will improve and give you less. It gives you other selection. This selection, you're going to process it again, and it gives you another proposed items. This, you're going to do the experiment, and you keep going. Sometimes you can do this loop maybe 30 times, 40 times, up to 50 times. And then you find at the end, you find a certain composition that is really good and it could be used, and it respond to your question at the beginning, what type of material I'm using, I should be used to get this mechanical properties. So actually, this is something new for me too. Last year in 2020, last semester, fall semester, we got, in our university, we got a grant from NSF grant, and the guy who, it's a group of people are working on it. I'm in charge of doing part of this. So it's something new, and we don't have we need to work with maybe another university because we don't have the machine learning models. Those are really expensive to get them, so it's better to work with another university who has it, and then we'll see if we got some results. I really I أنا أعيدكم, if we get some results. The results will take time, maybe 1 or 2 years. If we get some results, أعيدكم be another webinar and explain that, and I will understand more about this AI and ML. So this is all what I have to say about the AI and ML. If you have questions, otherwise we will go move to the next part 2, which is accreditation and testing.
عندنا سؤال من هلال. In material science, HPI diagrams are commonly used. How can AI and machine learning improve the exploitation of such diagram?
طيب، سؤال جيد. نرجع هنا لهذا. هنا نعم. شوف, when I did some experiment, the black dots, 1, 2, 3, 4, 5, 6, 7, 8 experiments. And I fit this, data. This is a data. This is a real experiment I did myself. So this, we see the curve. Actually, the orange one, it's the real. If you do all the data from zero, I don't know, from until maybe you do millions and millions to do this curve, the orange curve, which we can't. It's not feasible. It's not possible. So what we do, we let the machine, maybe you did some curve fitting in school, absolutely everybody. And the seminar, I mean the webinar of Murad Zero, that was very important. Optimization. This is optimization. You just see what curve will fit, will go through these points, um, will represent these points. So it's the blue one here. That's what the machine, the ML does. It just, there's several programs that does that. So many programs in the market, actually. Let me see if I have some examples of this. Some examples. ايش examples يعني هناك for example كاين واحدة يسموها random forest. هذه تستعمل to find this curve here to fit this data. When you find the curve, so the missing data will be found easily. The missing data, for example, بين هذه النقطة وهذه النقطة, there are so many data missing. So you will find them. So you see this curve is going through like this. So it gives you the missing data. حتى prediction in the future it gives you, because it's going to follow the pattern how this data is changing, and it gives you the right one. It gives you the predicted one, which usually it has a very good estimate to predict the missing data and maybe predict future data. هذا ببساطة. أنا اشتغلت في البي اتش دي، اشتغلت كثير في السيميليشن، في earthquake simulation, the acceleration versus time. This we call them time series. And the time series is really, complicated, especially earthquake. It's really complicated. Sometimes it has one peak, sometimes two peaks, sometimes three peaks. And how you're going to model out this complicated curve, which is going up and down randomly. And it's not easy to find a simulated curve that simulate the earthquake. Well, in there's a lot of so there's two big categories for that. There is a frequency domain and there is a time domain. Well, I did the time domain because it's easy and the acceleration is given in time domain, and you just have to find the correct way to represent them. This is one, now the machine learning model, it gives you anything you want. You can give her any data you want, any complicated like earthquake, it gives you a model for that. It gives you a simulation for that. And that's it. Even if there is some data missing, it will give you the missing data. And it's really close to the real one. أرجو أني أجبت على سؤالك.
نعم أستاذ مالك، بارك الله فيك. عندنا سؤال آخر من الأخت أسرة. I think she wants from you to repeat the point of sequential learning.
Oh, sequential learning,
sequential learning, yes.
والله يا أخت راني I'm trying to learn that too. I didn't try it, but that's how I understand it. Sequential learning. Sequential learning, that means you learn something, you learn a skill, and you use it for something. And when you use it, you get some output, you get some results. Those results will help you to be better. So these results, you're going to use them again to do the next loop, to use them for the next data, and that data will be improved. When it's improved, it gives you more accurate data. So, and you keep improving like this. You keep improving in this sequence. So here we have composition of material. This composition of material, it has manganese, sulfur, blah, blah, blah. You give them to the model, the machine learning model, and it gives you the best compositions that you are looking for. So you do some experiments, you test them for real, and you'll find a little bit different numbers, the accurate numbers you'll find, because in experiment, when you do the tension, compression, or shear, or torsion, you get real numbers, you get accurate numbers. These numbers, you feed them to the machine learning to get a new composition, and it will, you run that again and again and again. So it's sequential learning. It's you learn, the more you learn, the more you get your results accurate. Here, you know, wait, inshallah. When we get some results, I will give you a case study with numbers, with everything, and maybe you understand more, and we understand more too. I'm really learning in this type of studies, sequential learning. You know, when you mess up with this type of things, with material testing, I shouldn't say mess up. When you search, you really have to do a lot of research, a lot of reading, and a lot of experiments. Any subject that you take for PhD or master degree, and it has an experimental part, well, sometimes it takes time. If it's experimental, it takes a little bit of time, because you have to wait for the results. You do the experiment, sometimes you get some odd numbers, you have to repeat, you have to do some corrections, and you learn from your mistakes, of course, and you improve. That's exactly a sequential learning. It's what when you do an experiment, you make mistakes, you correct yourself, you learn, you do it again, you improve, you do it again, you improve until you get, you know, you get the right, you got very good output and results. نعم عبد المحسن.
نعم أستاذ مالك، على ما أظن كان في هناك تعقيب على أو ممكن
ماذا بي
مشاركة
تعقيب؟ معليش.
من نفس الأخت، ولا من نفس
Yeah, I like that.
الأخت هلال. I mean, what she said, I mean, machine learning may easily help the prediction of suitable material for a given application.
Not, you're right, but not a given application, for a given properties. For example, السي احنا when we هذه قاعد جبتها على testing. When we test, for example, here I do the testing to get these numbers, to get this number here, the yield, which is very important in design. So for example, and for this type of steel, he gave me only 401 megapascal. I need a little bit more so I can do good design. I need maybe this 401, it's gonna be 500. Why not 500? So I'll start looking for material, a composition of certain material for this ingredients, what you see here, the percentage, to give me a yield up to 500. That will, you know, that will be great for me, because I want to use it for design, to design certain thing. Then in this, you know, it's the property, this property sigma, why I need it. So machine learning helps you for that, helps you to do that, because it does things fast and it compares the numbers fast, and it can do millions and millions of combinations, which a human being cannot do it. You know, actually in the lab you can perform just a few experiment. Any experiment, for example, this test, it takes at least 1 hour, at least, in my experience. If you want to do a good experiment tension test, just, you know, assume that you're gonna spend one hour to prepare the specimen, to do it in the machine, to apply load, to plot the graph, and to get the data. It's a sequence. It's you know, a human. Even everything is digitized. It takes 1 hour. For the fatigue, for example, it takes time. You know, fatigue is not going to be done in it takes, because it's load that is applied again and again and again. Fatigue, um, fatigue, for example, العياء. It's when you. Let me give you an example for the fatigue here. I hope I find something here. I should have one. Unfortunately, I don't have. You know, when you take a pen, a paper clip, see paper clip? You take a paper clip and you start folding it back and forth. Maybe 5, 6 times, it will cut, it will break. That's fatigue. That's exactly what we mean by fatigue. So how many times here? Because it's thin and it's very very weak material, it will break. But when you use a shaft in a car, which is used again and again and again, thousands and thousands of times, there is a point where this shaft will get tired, you know, yeah, it's fatigue, and it will break. So as when you use things again and again, this limit here, it goes down. This limit here is going to go down. That's why, you know, previously, long time ago, when they design airplanes, sometimes they fail, they, you know, crash, and they don't understand why until they found out about the fatigue property, which is makes sense. Okay, anything else, Abdul Muhsin?
Yes, أستاذ مالك. هناك على ما أظن سؤال من خالد.
تفضل.
He is asking about, is there a possibility to use inverse machine learning to optimize? Here he's talking about the date palm تبع التمر yield, إنتاجية تاع التمر, and determine that, and this is agriculture.
Yeah.
So this
Could be, but
this is
like
agriculture.
yeah, I think just maybe it's a good question. It just look for the right place to find it, to find out. I have no idea. That's agriculture. شوف أهل الفلاحة يعني there is a lot of people who are doing a specialty in this type. So just find the right thing. I hope you can find the answer to your question.
If we can take the first part of the question, is there a possibility to use inverse machine learning to optimize
in
engineering, material engineering?
Yeah, material engineering. That's my topic in material engineering. You know, when you designing inverse design, it's very important. Inverse design, you have the properties and you want to find the composition. That's what that's the point. That's the main point here. And if we do that, I think I gave an example for the graphene. That's what the graphene went through. It took a long time, years, and they found a really graphene. It's a very good material. It's lighter than steel, 3.5 times lighter, and it's stronger than steel. It's really a good material. And the two guys who did that, they got the Nobel Prize. Okay. Any more questions, or we can go to the next point?
على ما أظن ما بقاش معنا أسئلة أستاذ مالك، فممكن ننتقل إن شاء الله next point.
Okay, here laboratory, it's here a little bit different. It's related to the testing, but it's now to the accreditation. What's the relation for our testing to the accreditation? Laboratory testing and accreditation. طيب, First, accreditation. ما هي accreditation? Accreditation is a review process to determine if educational programs meet defined standards of quality. See, it's all about the quality of education. It's a process that we have to go through to meet some standards which is set by the agency that is giving accreditation. Accreditation means a university or college went through a review process and achieved a level of quality. This is very important. يعني قبل أن هذا accreditation دائما يعني أنا my professor من باب الزوار عبد الحميد بن شيكو, I think he's I think now he's professor in Qubba. I don't know if he's still there. He usually when he gives a lecture, usually in physics, I took physics 1 and 2 with him. He make the connection between science and iman, and it's really very good. And I appreciate that when we went through a lot of things, he make the connection. And here in accreditation, يعني قد سبق المسلمون سبقنا في ذلك في الإجازة في القرآن الكريم. يعني هذه it's like it's more than accreditation. When you say إجازة في القرآن الكريم أو الإجازة في الأحاديث الشريفة, it's more than accreditation. It's kind of if a university is accredited, that means you can trust that university for your kids to go there, to study or to graduate from that university. It just trust. هنا الإجازة في القرآن نفس الشيء, يعني you need تقرأ القرآن على someone who's trusted, who has the إجازة already and he knows what he's doing. Same thing في الأحاديث. هذه يعني هذه كانت في القرون الأولى, يعني هذه الإجازات يعني كانت سبق, يعني تقريبا هي أحسن من الأكريديتيشن. هذه فقط ملاحظة اسمحوا لي أردت أن أضعها بين أيديكم. So two main type of higher education accreditation. كاين institutional accreditation. The entire university or college is accredited by either national or regional association. وهذه اللي موجودة في الجزائر الآن. It's the accreditation اللي موجودة في الuniversities في الجزائر. It's institutional accreditation. وكاين النوع الثاني اللي هو مش موجود في الجزائر, هي programmatic accreditation. هذه غير موجودة, ليس بعد هما. It's I think they are working on it, but it's not there yet. هذا مهمين جدا أن نعرف عنها. two type of accreditation. institutional accreditation يعني the whole university is accredited, وكان programmatic من civil engineering program, mechanical engineering program إلى آخره. كل department has a program which is going to be accredited by itself. والuniversity كامل لتحويهم it's accredited. فممكن نمثلها بهذا البيان, يعني the blue is the institutional accreditation. يجي تحتها program level which is all the department, والآخر شيء هو course level. Okay, so it's institutional. هنا هذه المؤسسة MSCH هذه في أمريكا هنا اللي تعطي الاكريديشن للجامعة. في الجزائر هي وزارة التعليم العالي والبحث العلمي اللي تعطي institutional accreditation for all universities which are all institutionally accredited. But program level, it's ABET. It's the agency that gives the accreditation هنا في أمريكا. وين كان يعني كل الاكريديشن مهما تسميهم محليا او عالميا هم متقاربين في الكونسبت تقريبا. واخر شيء هو الكورس ليفل اوف كورس. طيب benefits of accreditation. علاه why we need the accreditation. أولا the University of College achieved accreditation standards. كعود accredited معناها وصل للستاندرز اللي راهي معمول بها في العالم كله. ثانيا has proof of stability. This of course the university is when it's accredited, that means it's stable because it goes through a process. That process make it absolutely stable if you follow that process of accreditation. A good governance, governance, which is really governance. It's really a wide concept. It means accrediting body structure. It means policies and procedure. It's good. The accreditation criteria are met. It's peer reviewed, and also they have a good decision making, transparency and accountability. هذه قاع داخله في الجفرنس or continuous improvement. هذه كلها داخله في الجفرنس. الجفرنس له موضوع طويل وعريض في also it means has mastered self-evaluation and improvement. Any university which is accredited, it goes through these two things: self-evaluation and improvement. طيب, all this يدور حول what we call student outcome. ما معنى student outcome? Student outcomes هذه تستعمل معناها definition تاع student outcome is when the students, what all the students learn until the day of graduation. وتدخل الجامعة من السنة الأولى إلى أن تتخرج، كاع الحصيلة ذيك تاع اللي تعلمتها كاع هي ملخصة في هذه النقاط الخمسة يسموهم student outcome. هنا هما كانوا كثير يعني بصح بداو كل سنة they improve they update them. كانوا 11 ثم أصبحوا 9 ثم أصبحوا 5 now. شوفي هنا، شوف هذا الستودنت كم منين جايين استنبطوهم من البلوم تاكسونومي بيراميد. you know that. so هذا القديم وهذا الابديتد. so هذو السكيلز اللي راكم تشوفهم في البيراميد: knowledge, comprehension, application, analysis, synthesis, evaluation. وفي الترتيب يعني في أسهلها هي النولج، ثم تأتي هذو السكيلز تأتي بعدها أكثر أهمية هي الكومبريهنشن. أبسطها هي النولج المعرفة، then comprehension, then application, then في الأهمية analysis, synthesis which includes design, and then evaluation. تقريبا نفس الشيء هنا شوية they are modified but that almost the same. so هذو استنبطوا منهم student outcome which you can see here. so the highlighted one, that's the one that are related to testing. That's why I would like to mention this for to know that. so هذه number 3, ability to apply written, oral and graphical communication. This is very important. Communication, when you do the testing, when you do lab work, usually sometimes you do it in teamwork. Maybe 2-3 students, they do the same experiment and they write a report about that. So that's mostly the case. But some people, they do it individually. The experiment, of course, that when you're doing a research or something, you do that individually. But in the lab, which is a course in the university, at your program, you see your ability to apply the communication, how you speak, how you write, how you do graphics. Also, graphics is also a type of communication. And also this all موجودة في lab testing. Ability to conduct standard tests, measurement and experiments, and to analyze and interpret the results to improve process. You see, conduct standard tests, measurement, experiments, analyze, all etc. So this is important. That's how it's related to if students don't know how to do don't know how to communicate and don't know how to conduct a standard test. وهذا يؤثر في accreditation تاع الجامعة. It's not تاع program. It's not going to be accredited. Also, ability to function effectively as a member as well as a leader in technical team. Technical team, it's in the lab. So هذو مهمين جدا وهذو كلهم متعلقين بالاكسبيرمنت. When you do an experiment in the lab, I'm talking about mechanical engineering, so that's what we use. So الآن this حوصلة, this student outcome. You see, student outcome is skills. السكيلز اللي يتحصل عليها الطالب في الجامعة. هذا السكيلز كيف ننمي هذا السكيلز؟ هو هذا اللوب. اللوب is very important. هذه يسموهم continuous improvement process. continuous improvement process كلها يبدأ أول ما يبدأ ال continuous improvement process بالmission and program educational objectives. الميشن تاع الديبارتمنت أو تاع الجامعة. الميشن is very important. That mission is not it's not there just for the appearance of the جامعة. لا, mission عظيمة تاع الجامعة. It has, when you write a sentence in that mission, it means a lot. So it has to be well prepared, that mission. And also program educational objectives. Your objective in your program. For example, you are following a mechanical engineering technology program. What's your objective? What do you want to be? What do you want to reach? What do you want to get? So you establish the purpose and set goals, the goals of the program. هذه يقوم بها الفاكولتي في الحقيقة. الفاكولتي هم اللي they establish this set of goals. وهذا الgoals they have to be consistent with the mission of the university and the mission of the department. They have to be consistent. If they are not consistent, you're not going to get accredited. بعدها تمر إلى define and refine program outcomes like student outcome. هذا اللي شفناها من قبل. Student come, you revise them. You can modify them. So هذه اللي وريتهم لكم هنا. هذو they are proposed by the agency that gives accreditation, but you can modify them. It has all the skills, but most universities, they keep the same. But you have the ability to change a little bit in the wording, to change the wording, but don't change the skills, the skills that are in here. For example, here ability for knowledge and technique skills, mathematics, science, engineering, and technology. شوفوا the word engineering and technology. The word engineering, you cannot use it for any program. The program that is not accredited, you are not allowed to use the word engineering. word engineering هذا ما اتفقوا عليه في الاكريديشن في العالم كله أنه if you are not accredited, you cannot use the word engineering in your title. But they ما يقبلوها لكش, they don't accept it. You have to be accredited. Technology, yes, you have to be, it's good to be accredited, but they يقبلوها like technology means if you have, when you say جامعة العلوم والتكنولوجيا في باب الزوار. Technology, the word technology means most of the courses have lab. يعني they have labs. Otherwise, where are you going to get the technology from? Everything theoretical can't be. We are talking about the engineering and technology. These two words, you can't just use them anytime you feel to. No, it has to be, the university has to be accredited, and technology, you have to be some labs. Most of the courses should have labs. Otherwise, I don't know how you call yourself technology. وهلم جرا بقية السكيلز. طيب هنا وهنا في هذه عفوا yeah, when we define and you revise them, you revise the student outcomes, then you design and conduct assessment. Very important heading. You design, of course, the faculty. Who's going to do that? Design assessment. Assess what? They assess the skills. The skills, how do student outcome? They're going to assess them, evaluate them. Where to do that, we use some tools. These tools are rubrics, locally developed exam, surveys. This is the tools we use. There are some tools which are, we call them direct, and some tools which are indirect. Direct tools, which is the one accepted by the ABET or by the accreditation agency, they we use rubrics. Rubrics, it's just a way how to evaluate your students directly. It's the professor who maybe he knows the behavior of his student, he knows his ability, he knows his work, so he can can evaluate you, but based based on some work you are doing in class, and he's going to assess or use what we call a locally developed exam. It's not international exam, but it's local. It's in the university. It's the faculty who's going to do that. So he's going to design an exam. This exam, when he design it, he should look at here. He's going to make problems that has how to see if the students, how he's going to apply the knowledge, techniques, and skills, how he's going to do this, how he's going to does he have ability to design? He has to test that, all the processes, the media, the specific, etc., all this. And in the lab also, he's going to see if the student has oral and graphical communication and written communication through his report, and his ability to conduct the test, his ability to function in team. All this is going to evaluate them in rubric. Okay. So, and then document. This document, of course, is going to gather all these documents and use the results here. So he gather all the results and see the weaknesses of what weaknesses he has in this. Sometimes he see the percentage of students who are maybe 50%. They are less than they expected, maybe more than. He's going to set a target here to see if it's above the target, it's okay. Less than that target, that's a problem. So all the faculty will meet and try to solve that problem, that weakness in the students. When they solve it, then they do the next round. This from here to here, it takes 2 years to do that, 2 years. And the next 2 years, another round, he's going to correct what's the weakness of that student. He's going to correct it and do the loop again. That's improvement. That's why we call it continuous improvement process. Wherever any weaknesses, he's going to correct it and try to make it up for the students. Maybe when you correct an exam for a student and you see maybe 50% of the students in class failed. Here, you're going to raise a flag, of course. You're going to say why they failed. Let's see where they are weak. So you'll see the exam. Maybe they are, which student outcome they mess up in it. Maybe the 1, maybe the 2, maybe 3, maybe 4. He's going to analyze it and see where is the problem for the students. So we have less than 50% succeeded in the exam. So he's going to correct it. Maybe they see a weakness in here. So he's going to emphasize next year, next 2 years, he's going to do more effort in this one to make the students maybe he works hard in this one. The faculty has to work hard in this. Maybe he see weakness here, he has to work hard. Maybe he see weakness here, maybe in the design, they are weak, he's going to make an effort in this one. In this case, you will have a continuous improvement for your for the university. That's, you know, that's why the accreditation is really important. When you see this system running in a university or college, you'll see this improvement and these corrections they do. Of course, I like my, you know, I like to study in that university. I like to be part of that, or it's important. The accreditation is really important. I stop here. This, you know, there are some references here for you, which I used so far. So if you have any questions in the accreditation, I'll be happy to answer that.